Deformers can be a really useful and quite essential part of a modelling workflow, and you really shouldn't shy away from using deformers when you're modelling, as they can get you out of all sorts of sticky situations. Now, when it comes to polygon modelling, there are two sort of big guns in here. One is the FFD, which allows you to deform your mesh via a cage, and it can be very useful for making overall changes to the shape of your mesh once it's become quite complicated. Now, the other most useful one is probably the shrink wrap deformer. Now, the shrink wrap allows you to project your mesh or geometry onto another surface, and it really is quite useful when modelling. So I'm going to give you a couple of examples of this. So the thing that started off making it look grade 11 was that John was trying to model this little slide thing on the side of this gun. And he was having problems getting this shape here along with the rounded end of this piece. So as soon as I saw this, I thought this is a good case for shrink wrapping. I did a little demo for him, and that's how we kind of got started talking. So I'll show you an example of how you can use shrink wrapping to make this shape. So here would be the workflow. Essentially, I would start with a disc. I'll give this about 32 sides. Get rid of the disc segments. Make this editable. Grab my rectangular selection tool in point mode and just delete these points. Just go into edge mode, get your move tool, select these edges, and then just extrude out like so. The area that we want to slant is essentially these polygons here. Now, this is very difficult to do with conventional modelling because what we would have to do would be to kind of grab this edge and kind of move it down. But then we'd have to grab all these edges and try and make a flat surface out of these, and you would just run into a dead end. It would never be quite right, and I wouldn't advise doing it this way. So instead, what we want to do is take this object and project it onto another object that has this slanted rectangle shape. So to do that, I would just make a plane. Let's make this plane bigger. Now I want to keep this on the center axis so it kind of lines up nicely with the center line here. I can give this 2 segments a piece and just make this editable. I'm going to grab these lines, turn on my snap tools, make sure edge snap is on, and then just snap this over to here. Now I'm just going to cut a diagonal line here and just get rid of these lines by dissolving them. Turn off snap. And now I can just move this line up essentially until it lines up with the segment where I want to make the bend. So the shape I'm after is something that looks like this. So obviously the best thing to do is to take my original geometry. I'm going to move this up slightly. And then I'm going to go to my deforms list, hit Shift and choose Shrink Wrap, which makes it a child of the disc. And now we need a target piece of geometry here, or a target object. So I'm going to take my plane, drag that in, and now I have exactly what I want. I could hide this plane, and you can see the result that we get, and it's very, very, very easy to achieve. So modelling all of this kind of contour like this would be a bit of a nightmare. With shrink wrapping, it's dead easy. If I want to render the results of my shrink wrap here, I can just click current state to object. This makes a new object which has the shrink wrap applied to it. And now I could just come in here, grab this edge loop, extrude that down, hit T to scale, holding shift, and scale this to 0. And now I have this shape. So it'd be very easy for me to just kind of bevel this slightly, just choosing these edges, coming to my bevel tool, just kind of chamfer these out a little bit. Now you'll notice that I have a rather massive pole that I've done this on. You can see the bevel tool is freaked out, but I can rectify this by choosing uniform metering. Let's give it a couple more iterations of bevel there. Make sure our Fong break rounding is off. And here you can see the result in our viewport. Now you'll notice I have some faceting kind of around this edge, but there's not quite enough geometry to make it smooth. But if you think about it, this piece would probably be about this big in the viewport when you viewed the whole model. So I don't really think that would be much of an issue. Now obviously I'd want to make the rest of this mesh before I started beveling anything, but this is just an example of this shape and how shrink wrapping can help you achieve this effect. So here's a really good example of how shrink wrapping could help you out when modelling. Let's say you wanted to actually model the panels on this BB-8 droid. Shrink wrapping would essentially be your best friend for doing this. So you can see I have an image here that I got off the net that has all these panels laid out for you in an image. And I've started one of these panels down here. Now what I have is essentially a bunch of flat geometry that I've worked out. And we can see this in the viewport. Now this was created just using a simple disk, and the first thing we would probably need to do is work out how many segments we needed. So I'd essentially just play around with a number here, and I can see at 40 segments all of these lines are starting to line up very nicely. Now this probably wouldn't be enough geometry to complete the task, so I would immediately just double this and bump it up to 80. So all I have to do now is just make this editable. Let's come into edge mode and just start shrinking some of these edges down to meet some of the detail. Could then get my knife in loop mode and just start cutting along some of these kind of important lines where I know some of these features are going to be. Shrink that down, get my clone tool, maybe just clone another edge out to here. So then I'd want to start evening out this topology a little bit. Let's work on the outside edges here. Just trying to get these polygons a similar kind of size here. And then all I would start doing would be to start grabbing some of these panels and then just splitting them off and deleting them from the original geometry. And I would basically continue this process with all of these parts and further evening up all this topology until I arrive at something like this. And now I have all these parts kind of separated off, etc. Now to get the panel lines in between this, all I would do is just grab all these objects in polygon mode, select all the polygons, zoom in, and then I just want to inner extrude this a little bit, like so. And then hit UI to invert, delete, optimize, and now I have something that looks like this, which is all these separated panels as separate objects with a nice gap between them. Now, to create the rounded shape for this object, all I need to do is shrink wrap this onto a sphere. I have a sphere, it's the same size as the actual body, and I've given it a lot of geometry as this is going to give me a smoother shrink wrap. I actually need to see this. Now, I don't want to shrink wrap this individually, because that's going to take absolutely ages. So what I can do is take advantage of the fact that if all of these objects are in, I can select the null, hit shift, and then dump a shrink wrap into the null. Then all I have to do is drop my sphere into the shrink wrap. And if we come into our viewport, you can see we obviously have a little bit of a problem going on here. Now, this is due to the fact that all of these objects are sitting dead center in the middle of this sphere. So basically, the geometry doesn't know which end of the sphere to shrink wrap to. So it's kind of doing a little bit of half and half here. So what I need to do is just grab all of this, go to object mode, and you can see that if I move this very slightly in one direction, it will immediately shrink wrap to the side I've moved it closest to. And what I could do is just actually move all of this out. So it's kind of sitting just outside of the sphere. And you can see we get a very nice result here. So this would be your primary method of essentially doing all of these faces. Now, I picked a rather easy one here because it's basically a lot of shapes that look like they've come out of a disc. Obviously, some of the topology on these other shapes are slightly more complex, and we'll move on to looking at how we create this kind of geometry a little later on. But the process at the end of the day would be exactly the same. You create the topology flat and then shrink wrap it onto the object. Now you'll notice that I've omitted this circle and also these circular details here from the mesh at the moment. Now this is because when you shrink wrap, your geometry is projected along the normal face value of these polygons, so it's projecting straight back in Z. Now the problem when you project something like a circle, it's going to distort, and I've got a little example here of what I mean. So here you can see I've actually modelled this circle into this geometry, and we can have a look at the lines, and we can see our circle topology here. Now the thing is, if I shrink wrap this onto our sphere, that you can immediately see that this circular shape is being distorted. Now from the front view it still looks perfectly fine, but due to the projection we're obviously getting this distortion. So how do we correct this? Well, here's our circle piece of geometry here. Let's just center the axis on this. We can see this here. So in order for this to project properly as a circle, what I need to do is actually make sure my projection angle is actually straight on to this area of the sphere. So what I would need to do is rotate this object so it's kind of pointing in the direction that I want. And then I would move this kind of back into place like so. Now you may want to play with this, but this will give you a circular projection in the position that you want it. So remember, when you're shrink wrapping, you always need to kind of align your original geometry up with the object or the angle that you're trying to shrink wrap on. Now we obviously have a problem here where the rest of our geometry is all out of alignment. Now the beauty of shrink wrapping is that because all of this other geometry is obviously shrink wrapped, we can actually just take these points and move them, and because they're shrink wrapped onto the surface of our sphere, their shape is going to stay obviously perfectly spherical. Now it's also another good thing to bear in mind that certain tools don't work with shrink wrapping. Let's say the slide tool is a very similar effect to what happens in isoline editing with subdivisions, in that the tools don't actually work with the deformer on, and they'll snap back to their undeformed state. But you're fine, and you'll find this with the knife tool as well. It does work nicely with shrink wrap, so I can just take these points and move them along the surface of this object until I get the result I want. And now we obviously have a much better result in this area. So once you're happy with your basic shrink wrap, you can convert this whole null object into a new object by hitting current state to object. Let's hide that one. And now we have a version of our geometry which is actually deformed to this state. So from here on we could proceed with the modelling process. Let's say we select all of this, go into edge mode, grab our loop tool with boundary loop on, start selecting all the boundaries, and once we have everything selected, you can either grab our move tool or our extrude tool and just extrude these kind of faces back to give our panel some depth. Probably have to sort out our Fong tag a little bit. Now we have some panels with some depth, and then we could go ahead and possibly like subdivide this and then go in and sharpen all of this detail. That would actually be pretty easy to do as well. Edge mode, Fong break selection, say select all. Go to our bevel tool, solid mode. Give these a quick solid chamfer. We need to clean up some of that geometry, but you should get a pretty simple result out of that. And there you have all your panels shrink wrapped onto your surface. So the shape I have here would probably be useful for inserting these BB panels into. In this case though, I've given it some depth just to try something a bit different. So what we're seeing is basically a sphere with 6 holes cut into it. Now if I turn off the subdivisions, we can see the topology of this object. Now using a conventional sphere just isn't going to work because it doesn't have the right edge flow on all these sides to make these kind of cuts or holes possible. So essentially what we have to do is steal the topology of another object that maybe has 6 sides and wrap that onto a sphere. Now, can you think of an object that has 6 sides? Well, yeah, it's a cube. So it would be quite easy for me to bevel a bunch of holes into a cube and then shrink wrap that shape onto a sphere. So let's try that. Let's delete this. Now I'm just going to create a sphere first. Let's put this down to about 50. Now you can see on the sphere, the standard sphere, that we have this nice circular edge flow going around the top, so it'd be very easy to cut a hole in the top and bottom, but around these sides it's very square, and making a hole in these and keeping the sphere perfect would be a bit of an issue. Now we do have another sphere type here called the hexahedron, which actually has 6 sides, but again we also have this problem that the topology on each of the 6 sides is very square. Now I'm just going to keep this here. I'm going to jack up the resolution because this is what we're going to shrink onto. I'm just going to turn this off. And what I'm going to do is make a cube, divvy this up, 2 segments on each axis, make this editable. So now what I'm going to do is I'm going to select the center point of each of these surfaces. So I hit 9 to get my live selection, turn off only visible elements, and then I can just come in, just select all of these, make sure I turn this back on, come into my perspective view, I'm going to grab the bevel tool. I'm in chamfer mode. I've got subdivision set to 1 and depth set to -100. And when I bevel out, we can see these holes starting to appear. Now, once I get past the halfway mark here, my end-on line should switch to meet the corners. And that's the halfway mark between this point and this point. So now I have a bunch of n-gons here. The topology's right, so I can just go to n-gons, remove n-gon lines, or remove n-gons, and that should convert all those n-gon lines into edges. Now I can just come in and delete these points to create my holes. Just spin round here. And now I have an object with 6 holes. Now currently this cube doesn't have enough geometry to shrink well. It's a little bit low res. So what I'm going to do is just subdivide this, give it 1 subdivision, get my subdivision object, hit C, make it into an editable object. And now I have slightly too much geometry. I kind of want to keep this a little bit more low res than this, so I'm going to go in, select these edge loops and just dissolve these. And now I think we have a mesh with sufficient resolution, and this should work pretty well. So now I can go deformers, hold shift, grab a shrink wrap, make that a child of our object, and then drag the sphere into the target object. Now nothing's happened because my sphere is turned off, so I turn this on, and I might have to just refresh the viewport here, and that's done it. And we can see, if I hide the sphere, that our geometry has indeed shrink wrapped onto this. Now the problem is here that the sphere is a little too small, so I can just enlarge the sphere a little bit. And now I'm getting pretty close to what I want. So you can see we're kind of getting a pretty good result here. And I'm just going to subdivide this and have a look. Now you can see that where I don't actually have enough geometry at present, I'm getting some bending towards these holes, and I need to establish a little bit more curvature into this mesh. So there's a quick fix for that. Now you'll find yourself doing this quite a lot. Sometimes you may need to shrink wrap this more than once. So what I'm actually going to do is turn my object and shrink wrap into a new object. And that actually renders down the deformer. Then I'm going to subdivide this again, just with one iteration. Hit C, Shift, add another shrink wrap, drag my sphere in, and now watch how the object becomes more spherical. And we can see the difference that's made. So that's actually pretty good. I'm happy with that, so I'm just going to render this down again, delete my old one. You may want to keep copies of what you've done just so you can go back if you mess it up. But this is looking pretty good. So now I just want to select my object, go to Simulate. I'll do this with cloth, put it in a cloth surface, take off the subdivisions, and then give this some minus thickness. Hit C. And now I essentially have the geometry I want. Now if I want to subdivide this and tighten up these edges, I can just go to Select, Fong Break Selection, Select All, grab my bevel tool, solid mode. This is currently set way too high, so I'll bring this down, make some cuts there. I can put this into a subdivision, and there I have the shape. So this process of shrink wrapping, rendering it down, giving ourselves more geometry by subdividing, again rendering that geometry down, is a fairly common workflow. Now we'll probably be seeing some shrink wrapping as we go on, but this is incredibly useful if you're in a conundrum, you don't quite know how to achieve a certain type of topology. Chances are you can just steal it from another object. So here's another quick example of how shrink wrapping can help you when you want to conform the back face of one object onto the surface of another object. So I have this cylinder here, and I've placed my modeling axis for all these polygons at world center, and this is the same coordinate as our sphere. So basically, no matter which way I rotate the cylinder, it's always going to look like it's perfectly adhering to the surface of this sphere. So I could create an effect where I kind of bevel the back edges here and make it look like it's kind of sitting on the surface as a separate object. But what happens when you have an object that isn't so perfectly aligned? You can see I have another cylinder here, and this is kind of sitting on this at a very different angle. Now, to make this back face look like it was the same shape as the sphere, you might think that you would have to kind of cut round this cylinder with a knife and kind of match the knife cuts to the surface of the sphere, etc. But you can actually do this very easily with shrink wrapping. So I'm going to grab my cylinder, I'm going to give it a few more edges, about 24, and this is because I want to have enough geometry to get the definition of this surface as I want to subdivide it. If you weren't subdividing and you wanted to keep this as regular geometry with bevels, you would have to obviously increase the edge count kind of considerably to get the definition on the curvature. But for our case, 24 will do quite nicely. Let's make this an editable object. Hide our sphere. Select the back polys. Inner extrude. Delete. Loop tool. And now I'm going to delete this loop. So basically I have the front and back. Select this loop here. I'm going to go UP to split it off and then delete it from the original object. So now I have back and front as separate objects. I'm going to grab the back face, shift, shrink wrap, and drop my sphere into the shrink wrap, which conforms this surface onto the sphere. Now I can take this object, current state to object, delete the old one, connect these two together, edge mode, grab these two loops, stitch and sew, polygon mode, Make sure all my normals are aligned. Edge mode. Solid chamfer. Subdivide. Unhide my sphere. Turn off our lines. So now this object looks like it's been manufactured to perfectly fit this sphere, and with a bit of ambient occlusion that should look quite nice. Now this will work with practically any shape onto any surface as long as you have the definition or the geometry count in the object you're trying to do this with, so it conforms to the shrink wrap surface. And you can get a lot of interesting effects using this technique.